Okay, my assignment that I had my students doing is an activity with a pair and trying to understand quadratic functions. So with quadratic functions, there's three methods or three ways that students can actually solve them. They can solve them by factoring, they can solve them by the quadratic formula, and by graphing. So based on the problem that the students will be getting, they'll be getting real world problems, and they will have the choice or the opportunity to actually figure out how to solve it. So if they can do it by factoring, they'll do it by factoring. If they do it by the formula, they have to do it by the formula. And pretty much each of these auras helps them figure out what to do. So this is going to be like an introductory to the actual lesson. And students will have examples throughout these auras as well as explanations of how to actually use specific things to help them. So for instance, if students had a problem they couldn't factor and they had to use the quadratic formula, they would come up and see this aura and they would scan it with their phones.
The quadratic formula is used to determine the zeros of the function. The zeros are also known as the x-intercepts. The quadratic formula consists of coefficients and constants in a quadratic equation. The coefficient of x squared is labeled a, the coefficient of x is labeled b, and the constant is labeled c.
Once they hear that, it'll be a little bit easier for them to actually figure out how to use the quadratic formula. Next, they could actually see an example by clicking on this aura.
After you locate your A, your B, and your C numbers from the quadratic equation, you want to substitute those numbers into the quadratic formula. So as shown in the example, you have all the numbers now in place of A, B, and C. After that, you want to simplify all the numbers as much as possible. Where in the end, as you see in the example, you come down to 5 plus or minus the square root of 1 over 2. The square root of 1 is 1. That plus or minus in the middle of the two numbers on the numerator identifies that there's going to be two solutions. In the end, you should get two solutions that will be the x-intercepts of your quadratic formula.
With that example shown, students will be able to understand clearly how to actually substitute information in. Once they are done, they have the opportunity of coming to this aura, which I think is a very interesting way on how to remember the quadratic formula. I actually remember it this way from when I was in high school.
The quadratic formula's negative b plus or minus the square root of b squared minus 4ac all over 2a.
I think hearing that song is actually going to benefit the students because, one, it's kind of fun and goofy, and I think it'll engage the students a little bit more, and it'll also help students that have a hard time remembering certain things, that when they can relate it to something from when they were younger, it's a little bit easier to understand. Now, the other auras that I have are to solve by factoring, which here provides an example of what they will actually do.
Solving a quadratic equation causes you to look at the factors of the constant term. The factors of 15 are 1 and 15, as well as 3 and 5. 3 and 5 are the only two factors that add to a negative 8. Okay? According to this, though, 3 and 5 both need to be negative in order for them to add to a negative 8. Now you want to break up the quadratic into two binomials. Place those numbers into the binomials next to your negative signs, and there you have a factored form.
This will show them a nice example of how to actually factor, because it is going to be a fairly new concept to them. The only previous knowledge they will have is actually getting factors of numbers, which they learned in elementary school. Then here, once they figure that out and once they factor it like that, they can actually see how to solve. So it's only one further step of actually figuring out the x-intercepts with here, they figure out using a t-chart, which did not appear too well. But all it is drawing a line down the middle of the binomial and setting each equal to 0 and solving for x. And then lastly is students also need to understand axis of symmetry. And the axis of symmetry is usually taught through graphing, because it's a vertical line that passes through the vertex. Once they know that, they can graph any point they want on the parabola, knowing that each point is equidistant on the opposite side of that line. So what that aura does is shows actually how you can graph it. If, say, your battery in your calculator broke, students will be able to use the axis of symmetry as well as factoring or the quadratic formula to actually find the x-intercepts. So after they go through these auras, they'll have the correct knowledge to help finish the activity. And with my students, they like to be very competitive, so the way I made this as a game is the first one to go through all these stations and complete the actual questions completely and correctly, they'll get a prize. And it will either be 5 points on a test, or they could get a homework pass. But that's how I feel my students get extremely engaged in math and understand it fully, is through competition and through like relay races and little station activities. So I feel like this would be extremely beneficial, and especially because these kids could use the auras and actually take their time and go through it and listen to it again and hear my voice again and go through it. And I think having a partner, it will help them learn it also in another way if the partner has a better explanation. So that's my thought and my use of my auras.